Alright, praise God for another day, another opportunity. Thank you. Thank you. Thank you, everybody. Oh, not thank you, everybody. Thank God for everything. Thank you, God. Thank you for everything. So, here we are with another problem. And, keep my volume kind of low. Or keep the volume kind of up, keep my voice kind of low. Let's get into it. Minimum number of arrows to burst balloons. See how we do. Let's see how we do. Yeah, the last one was a prime opportunity to solve a problem in 4 minutes. But I didn't read the whole problem, I guess. So, unfortunate. Some spherical balloons spread in two-dimensional space. Oh boy. Each balloon provided input is the start and end coordinates of the horizontal diameter. Since it's horizontal, y coordinates don't matter. Okay, and hence the x coordinates of start and end of the diameter suffice. Start is always smaller than the end. Okay, I don't really understand, but okay. Arrow can be shot up exactly vertically from different points along the x-axis. A balloon with x start and x end bursts by an arrow shot at x. X is less than or equal to x. X start less than or equal to x less than or equal to x end. No limit to the number of arrows that can be shot. When an arrow one shot keeps traveling up infinitely. Given an array of points where points of I is equal to x sub start, x sub end, and the minimum number of arrows that must be shot to burst all balloons. Okay, so I guess alright, interesting question. So points 10, 16, 2, 8, 1, 6, 7, 12. So I think this is basically like intervals, right? Like I think it's the same question that we just saw before with the how do you remove how many intervals do you need to remove, I guess, or how many what do you call that? How many intervals do you need to remove? It's very similar to that overlapping intervals question where you need to remove a certain number, the minimum number of intervals to remove so that the balloons are not overlapping. Or not the balloons, the intervals are not overlapping. Well, actually, in this instance, what you would do is you do the same, you literally can do the same algorithm and then just take the difference between the total number of intervals and the count, the intervals that you removed. And that's the number of non-overlapping intervals, I believe. Although the definition for overlapping intervals is a little bit different over there. I think here these intervals are actually, these would be considered inclusive on the endpoints. So they're not open endpoints, but they're closed endpoints, meaning if you shoot an arrow here from like 1 to 2 and 2 to 3 would actually be considered overlapping, whereas in the previous case 1 to 2 was not considered overlapping. So excuse me. Yeah, I mean, we want the minimum number of arrows, so I'll think about this also in a similar way, but I think this shouldn't be too difficult. One way is to shoot one arrow, for example, at x equals 6, bursting balloons 2, 8, and 1, 6. Another arrow at x equals 11, getting, you could also go to 2 and 10, right? 2 would take out 1, 6, and 2, 8, and then 10 would take out 7, 12, and 10, 16. Interesting. So actually what we want to do is group the overlapping intervals, I guess maximally, such that yeah, this is a little bit different. It's not really grouping the intervals, if they're overlapping or not. Really what we're looking for is the points that have the most grouped intervals, sort of. Not even that, really, because you could be in a situation where even though, I I don't know, I want to say like three sections that would get all the balloons. Like you'd take 3 points, or rather, okay, yeah, it would be 3 points. But if you take one particular point that's the maximum, the greediest, you'd be stuck having to deal with 3 other points, which would be 4 instead of 3. I want to say something like that. Or even just a simple load balancing thing where, yeah, 2 to 3. So if you're trying to somewhat load balance the positions you pick, because if you pick the greediest position and that deals with a maximum number of intervals, you might be left in a position where there are 2 intervals to the sides that weren't addressed, that would have otherwise been addressed. So you can think of it like almost like a diamond, I guess. Yeah, you can think of it like a diamond. So you'd have 1, 2, 3, and I'm just thinking. Yeah, you can have like 5 intervals where A overlaps with B overlaps with C overlaps with D, and D overlaps with E, but there are no other overlaps beyond that. And then, how can you get to a situation where you wouldn't take the maximum every time? Well, those would be 2 for all those maximal 2 intervals to remove all those maximal positions. I'm just thinking if there's like, if there's like, now you have an interval that covers a lot of things, I guess. I don't even know. I'm not sure. Actually, it feels like maybe a greedy algorithm is just correct. Maybe a greedy algorithm is just plain correct. Well, the reason why the greedy algorithm might not be correct is that if you remove a large number of intervals, then the other possible positions might be reduced in terms of what could be removed. Like maybe the greedy position is only good because you have intervals there that cover a very large range, and actually there could have been a better position that you would take where you would take care of something that only 1 or 2 things are overlapping with. Yeah, something like that. Huh. Just thinking. Actually, yeah, that's a good example. So let's say you have 1 interval all the way to the left, 1 interval all the way to the right, and then like 2 intervals on the left and the right. So 4. So 2 on the left, 2 on the right. So 3 on the left, 3 on the right total. One of the ones on the left is very small. It doesn't really overlap with anything on the right side, and the one on the right side does the same thing. So they're somewhat self-contained. So you're going to need 2 positions to take care of those. However, the other 4 all overlap in the middle. However, on both sides they overlap also. Like so the ones on the right only overlap with each other and the sort of island on the right, and then all the way in the middle there's a slight overlap with the mirrored picture on the other side. So there's like sort of two kind of, looks sort of like this kind of a picture with the islands on top. And now if you go for these 4, you still have to take 2 on the left and the right. So that's an example where the greedy algorithm would be incorrect. because that would be 4, 3, and 3. You would go for 4, then the other ones drop down to 1 and 1, but they don't overlap. But if you go straight for the 3 and 3, then you take care of everything in two positions. So the greedy algorithm is wrong. That's a counterexample. Nice. But now, what's an algorithm that works? What's something that works? What's something that's correct and that's relatively efficient? Well, I don't know. You kind of want to break this up into pieces that don't overlap with each other. Like you can kind of imagine like two quote unquote connected components in some sense, where these two islands don't overlap. They're not really connected to each other, I guess. They overlap with other things that overlap with each other, but they don't overlap themselves. Trying to think if there's some kind of a graph problem analog. I don't think so. I think these interval questions actually makes them harder when you try to compare them to graphs. How many integers do we have to look through? Okay, that's the whole range, so we can't just go. All right, we're gonna be a little more clever then. Thinking, how do we do this? Would be a correct algorithm that's relatively efficient. What's a correct algorithm that's inefficient? I mean, can't just try every combination. That doesn't really work. What can we even do that's like even quadratic time? To find the minimum? Well, all of the points give us a set of values that we can try, right? Like we could always try like the leftmost coordinate, I guess, the x starts. I sneeze. We could reduce the set of positions that we're concerned with to only those x start coordinates. Set of coordinates that we're concerned with to those x star coordinates. And then I guess, I mean, really inefficient would be just try all possible subsets, and of the ones that are correct, take the minimum, the one that used the minimum size subset. That's one way. Another way is to maybe try to figure out which ones would be correct, which would actually be correct. Probably like which try to find these correct subsets. What would they even be? I don't know. Like I said, there's kind of like some overlap going on. It's not really. We don't really want to split this up into a graph problem. I don't think so. I think you want to get, for each interval, you want to take the point at that interval, because you have to get every interval anyway, right? So you want to take each interval and take the maximum for each interval, right? Like I think that's correct. Yeah, for each interval, the maximum number of overlaps that's going to be what you want to take for each one. So yeah, yes, and it's going to, for each of these points, it's actually going to overlap somewhat. Yeah, so for the first interval, the maximum number of overlaps, basically, I think what you can do is sort. You can just sort by the x coordinate. Or call them x and y, right? X is the start and then y is the end. Sort by the x coordinate, and then just see what's the furthest to the right. You can actually do a binary search to do an upper bound to find how far, for that interval, how far over is really what you're looking for is the first x coordinate that's to the right of your y coordinate. That's greater than your y coordinate. Not just greater than or equal to, but greater than. And everything to the take the difference between those pointers, and that gives you how many. That gives you no, that's not good enough either, because this could be overlapping a bunch of other things too. So, like, you could have one very long piece and then a bunch of pieces in between that are, no, that's not what you want either. No. No. How do you find for that piece its maximum overlap points? All the x coordinates where there is a maximum, and then all the x coordinates where it reaches that maximum. That's tricky. You can actually, no. That's really hard. That's really tricky. You also want to sort by probably by the shortest b value as well. So left to right ascending on the the y value, or ending value. So left to right ascending on the x start, and then for each of the ones that have the same x start, you would want to sort, I guess it would be, the ending also ascending. So the y value also ascending. So sort on the x ascending and then sort on the y ascending. And the reason for that is, I think what you would do is you would look at if the next interval to the right overlaps with the first interval, then if this one is encompassed by the first interval, you'd want to approach things differently, we'll say. If it's not encompassed, then actually I don't even know. Say it's not encompassed. Well, you would want to count all the intervals that have the same x coordinate and then take the one. All you would want to use that x coordinate right then and there, I think. If you have multiples, probably, so you're going to capture all of them. But all of the ones that are larger would automatically encompass the smaller one. So anything you do with the smaller one will automatically include all the larger ones. So that'll probably be the optimal point for that point, as well as all the other points of the same x start coordinate. Something like that. I want to say something like every point will contribute one x coordinate that you want to use. And some of them will cover the same x coordinate, and for those ones that do, then you're in good shape. That means that you don't actually need to add any more. You can sort of use the idempotent property of sets and just keep going, right? That basically means that that section of interval shares an optimal point. All of those will find the same point too. But the problem with that is, how do you figure that out? Even for just 3 intervals, right? What's the point where, let's say, all 3 of them overlap, or the largest number of them overlap? For the first interval, largest number overlaps to the second interval, largest number overlaps to the third interval. That includes each of those intervals, right? Largest overlap that includes the first interval, largest overlap that includes the second interval, largest overlap that includes the third interval. How would you sort that out? Well, clearly you can find the next interval if you sort by the x start positions. The next interval would be second. Let's say called the second interval, or the right neighbor. There could be no overlap there, in which case, and you could just take the x start of the first interval and then you're done, right? Because if that doesn't overlap, nothing else is going to overlap, right? So it overlaps or it doesn't. If it does overlap, then you want to update the optimal coordinate x, the start coordinate x coordinate, to be the further to the right, that x start coordinate for the second interval. That'll be the best. That'll be the new best for the first interval. Now the question is, that's also the current best for the second interval, right? But we're not doing that yet. I haven't figured that out yet. If we look at the third interval now, does that overlap with the second interval, and does that overlap with the first interval? See, that's a tricky question, because well, you definitely need to use something for the second interval that will also take care of the first interval. Is it maybe better? You need to take care of the second interval. So if the third interval doesn't overlap with the second interval, you don't need to keep considering the first interval at all, because you have to get rid of the second interval, and it's better to well, yeah. So if the third interval doesn't overlap with the second interval, then you can move on from both the first interval and the second interval, because no other interval is going to intersect with the second one. Even if the first one encompasses some other things, you still can get rid of the first one for free when you get rid of the second one. So you can actually just save that x coordinate for the first and second, and then kind of continue where you were. So that sort of reduces the problem by 2 intervals, and continue on number 3. If number 3 does intersect with number 2, then the question is, does that intersect also with number 1, right? And the question is, It may or may not. Yeah, so if it intersects with number 2, if it overlaps with number 2, then actually you're going to want to update your optimal for the second one to be the third interval. It's the beginning point. Excuse me. Yeah, you're going to have to update your second interval's optimal point to be the third interval. If the third interval overlaps the first, you also want to update the first one to the third interval. So that's kind of a tricky thing. Excuse me. So that's a really tricky thing. Let me lay down for a minute or two. Let me just ponder this, because what I'm trying to do is figure out efficiently for each interval what the best point you'd want to go to get as many things that are overlapping that interval, and do that efficiently per interval, and try to go for like an n log n algorithm. But it's not obvious how to do that just quite yet. But I think sorting is definitely encouraging. Like, it looks like it's probably going to be a fruitful first step. We're already 20 minutes in though, which is kind of rough. I think it's probably going to take another 20 minutes to think about it, and probably at least 20 minutes to code it. Did you consider the bathtub problem-solving streams? What's up, Yuki? Welcome back. Hello. Bathtub problem-solving streams. Like problem-solving from the bathtub. I appreciate that. I actually don't have a bathtub right now. So I guess that's that. I don't have to explain why I don't. What is it? Don't want to be a degenerate, or don't desire to be a degenerate. I've heard that apparently on Twitch, people are. Oh, my sister called. I should call her. I'll probably call her after the stream. I have to remember to do that. I was like scrolling on YouTube and came across a video where people were criticizing. They're saying, "Oh yeah, people on Twitch are taking, they're doing streams in bikinis in a hot tub now," which is like really ridiculous. Excuse me. Yeah, I'm not really. There's kind of a lot to say about the internet at large, and like humanity at large, I guess. But like, I was because I don't know. It's kind of a. I want to say it's kind of a long story, but basically I was like, oh yeah, I got to get off of Twitch because it's corrupt and there's all these things. One of them, obviously, kind of the degeneracy is like the hot tub streams, right? Like, right, young scantily clad women in the hot tub, getting money from strangers to do that, right? Like, that's an example of like just like moral degeneracy. But my thinking was like, oh, I can't be a part of Twitch because it's degenerate, right? And then it's like, well, I can't really be a part of YouTube either because it's also degenerate. And then it's like, I can't really be a part of the world, can I? Because it's like these things are just like representations, normal representations of humanity, right? The Bible kind of points that out. That the basic idea is that we sin. We don't do right by God. We don't want to do the right things. Like, our sinful nature is constantly pushing us to do evil, wicked, questionable things that we want to do. And like, the idea is, not my will but yours, right? Or my will but not yours, right? Depending on which perspective. So your will being your own, and my will not yours, referring to God's will. So my will not God's will is like the normal thing to do, to sin. And then the opposite of that would be, the Christian tries to repents and says, not my will but yours, God, and referring to God's will. Not my will but God's will. Be done. And the whole story with Jesus is that he was the only man that actually did that to ever live, right? Every man has fallen short of the glory of God. And the only way that Jesus could have done that was because he was God. And there's kind of a lot of other reasons why he's God, but excuse me. He's the only man that wasn't Only man that ever lived that wasn't a degenerate. It's kind of what I'm getting at. So I'm kind of like, what am I trying to even do? Trying to avoid YouTube or avoid Twitch or avoid this or avoid that? Like I don't even know. Should probably just avoid most things, I guess. But I don't know why I brought that. Oh yeah, because why I'm not on Twitch anymore kind of reminded me of you talking about bathtub streams, and apparently they're doing that down on Twitch now. So it reminded me of that. I was like, oh, okay. Yeah, I've been thinking about that problem. It's like, yeah, it's like no escaping the world being really corrupt, is there? Like I can only pray to God that I don't get wrapped up in too many horrible things. I guess too many. Yeah, I don't know. So I'll figure it out. I'll figure it out one way or the other. But yeah. It's really sad. It's really sad. It's the thing with young women. I've been thinking about that a lot lately too. About like fathers and daughters and authority, and like this idea of like, as a father you'd want to give your daughter to a man that you trust, right? Like she's going to marry this guy, he's going to take care of her. You don't want to just like throw her away to somebody that's going to mistreat her or take advantage of her and leave her behind or anything like that. And that kind of idea that like there's even a story in the Bible about Dinah, who was actually Israel, one of Israel's children, daughter. And I think there were 12 brothers, 12 tribes of Israel, and then Dinah was the 13th. Now, I don't know if she's the 12th tribe, 12th child, or if she's the 13th child, and she doesn't get a tribe in Israel. I don't actually know how that works, or if that's how it went. But I know she had at least 11 brothers. I don't remember if it's 12. And the deal was, she went out to hang out with some Canaanites, I think, when Israel and his children went to, which I think Jacob was Israel. His name was Jacob, and then he was given by God a new name, Israel. And he went out to a land actually to conquer it, I think. But he was peaceful with the people for a time, and his daughter Dinah went out there to go meet the people, the locals, and she ended up having sex with one of the locals, right? I guess one of the locals was a prince in the land, and he liked her, convinced her to sleep with him, right? I don't think it was rape. I think it was just, he wanted to do it, and she's a woman, and I guess that was the kind of thing that was kind of jarring to me. It's like, yeah, in my experience, women are not really they're not like men, they won't, not that they won't resist if they don't want to do it, but they might just want to sleep with you. If you just walk up to a woman and say, I want to sleep with you, she might just do it. Right? Like, it's something about that. Because I figure on the other, you switch roles, and that's probably true too. If a woman just walks up to a guy and says, sleep with me, she's a very attractive woman, that'll probably happen, right? And vice versa. If a really attractive guy walks up to a woman and says, sleep with me, she probably would say yes. So, not necessarily rape, right? But it was still wrong. And in the story in the Bible, the brothers of this woman of Dinah, the children of Israel, what they decided to do is they tricked this guy. This guy said he wanted to marry this woman, Dinah, and they wanted to kind of fuse their families. I'm kind of shortening the story a bit, but then the Israelites said, "Yeah, sure, let's do that." And then, excuse me, sorry. Then basically the Israelites, when the Canaanites had their guard down, the Israelites murdered all of them. A few of the brothers, I think, gathered some servants, and they went and they killed all these guys, including the prince that wanted to marry Dinah. Right? They just slaughtered all of them. And the reason they did that, they said, was, well, actually, they didn't give a reason at first, and I think they gave a reason, but their father Israel said, "Why'd you do that? Why'd you kill all these people?" you're messing things up for me here, because now all these people are going to try to come after us, all their their relatives or whatever, their extended family, and the brothers, their answer was, well, what are we just going to let this guy treat our sister like a whore? Like how and let him get away with that? We can't let that happen. We can't do that. Like a prostitute. And I thought about that, and I was like, I've been thinking about that, where that seems to be somewhat like there's like a lot to read into that. I guess one thing is that murdering everybody wasn't right, so clearly they weren't supposed to do that. But the guy wasn't supposed to pick up their sister like that either, um, and so that wasn't right. And I thought about it, and I was like, yeah, I mean, basically, it's like stealing. It's like stealing someone's daughter, right? Um, and I thought about it, and I was like, yeah, that seems about right. That actually does seem like because the father really has no say, right? Because he can't undo his daughter sleeping with somebody. Um, so he cheated his father out of a choice, her father out of a choice, by taking advantage of her being a woman. And apparently, women are relatively easy to take advantage of too, I guess, which also seems to be my experience. Which I know the Bible is it's about us, so it's probably correct. Um, it's a difficult thing. It's a sad thing. But I've been pondering that. I was like, yeah, that's what they call fornication, right? Sleeping with someone before you're married. And what's crazy too is that even though he actually wanted to do right by the woman and marry her, the brothers were still so frustrated by this that they killed him, which is also interesting. Um, but the Bible did make it clear that that wasn't right what they did, or at least Israel didn't think that was right. Um, so I don't know. I mean, it's weird. It's my notion of how I guess courtship works is kind of I don't know, because a lot of the experiences I've had have been really confusing and jarring, and like I don't really understand a lot of stuff. And I think how it's supposed to go ideally is that the father decides who dates his daughter. I think that's how it's supposed to go. Um, and she's only supposed to date one guy that she intends to marry. She's not supposed to be dating like a whole bunch of guys at the same time. Where dating here is literally just spending time with somebody. So that whole kind of idea, like that makes a lot of sense to me. Like that, I can understand that. I can handle that. I can deal with that. It's very clear the boundaries at that point, right? Like it's very clear. This woman you're dealing with, she's not married. She's not dating somebody else that she's trying to get married to. You're not violating anything. You're not hurting anybody. It's like it's very much. You asked her father. Her father kept her, um, what they call it, separate from men, more or less, until she was ready to actually date somebody for marriage. Like it's very controlled, I guess, in some sense. It's not just like utter chaos, which we have today. Today, it's like complete free for all. I mean, people kill each other over this stuff. Like I can't even comprehend it. It's like what is going on? You got people dating other married people, and then their husbands get jealous and they kill each other, and it's like what craziness is happening here? And excuse me, these women that get married, it's like they had already had like another husband or two. Like it's like they're not even, or they had guys they had slept with before they got married, and it's like that might be one of the guys that kills her new husband. It's like it's just complete insanity, like just derangement. I can't even approach it. A lot of this stuff, these different things, these stories. And sorry, I'm not even looking at the chat. I'm just kind of rambling on. Um, One of the things, though, what is it? Trying to remember. There's something there I wanted to say. Um, uh, yeah, I don't know. Like, there's this thing going on with women that it's like they don't even consult their fathers. They don't even. That's not even. They themselves are not really concerned with finding a guy to marry. They're just kind of sleeping with any guy around, and I don't know. I mean, it's very like I said, it's hard for me to comprehend all this stuff. Trying to do the right thing, right? Like that's the idea. Try to do the right thing. Um, women divorcing and getting married and looking, even though they're married, still looking for another guy. Like all this really bizarre and chaotic behavior. Right. I forgot where I was going with all that. I guess. Why is that related? Um, I forgot now. I brought that up. I think. I don't know. I don't remember why now. So I guess it's just something on my mind. Well, I think it ties into. I'm sorry if this bothers you if I say this, but I think it ties into homosexuality too, because it's like I kind of see all of that stuff as like confusion and sin, and I kind of also see homosexuality as like a similar, like a close cousin in terms of like the confusion and the sin. Um, I don't know, something about it, because I've been kind of learning about um, homosexuals and homosexual behavior, and like I very much do think it's kind of similar to other sins where there's just abuse and depravity and derangement and all kinds of stuff going on usually that's somewhat tied in, somewhat related. Um, anyway, so I'm giving myself kind of a headache here, thinking about these things are kind of sad and kind of painful. But yeah, I don't know. I've been somewhat reflecting on like I've been trying to understand my place in the world, my life, and some of the experiences that I've had. Some of them really painful, some of them not so painful. Um, anyway, okay, I don't know. I'm just rambling on now. But the reason why I brought that up about I had an experience recently where I kind of went off on somebody and expressed, it's like, oh right. I remember why. Now I remember why. Right. Um, yeah, this idea of like sleeping with somebody and not marrying them is like extremely disrespectful. If it's a woman, right, having sex with a woman and then kind of dumping her off to the world to have some other poor schlub pick up the pieces is it's really evil. Because you only really have two options: either you break up or you get married. And I see that a lot. You know, I've seen that a lot. I see it a lot, and it's hard for me to like care about women because of that. Because it's like, well, I'm gonna have to watch that happen. Like most women, if you befriend them, you're gonna have to watch that happen. It's really, really frustrating and sad and difficult. And the thing that's crazy about it too is that they won't appreciate you telling them about that unless you're like already very close to them, I guess. Um, but in that case, it's like, well, why, why did you get really close to a woman that you're not going to marry or date? It's just kind of, it's really difficult. Um, and if there is a woman you want to marry or date, why would you be really close to somebody else and not her? Basically, it's competition for her to make her uncomfortable, I guess. So there's just this. I don't know, man. I'm just kind of rambling on here, but your presence kind of reminded me of some things, I guess. And so forgive me if you were not expecting that or didn't appreciate that. I'll read your comments too in a minute. Let me just back to this problem that we're working on. Yeah, I think it seems that we're looking for for each interval. We want to find the optimal point to cover as many as other intervals as possible. And the thing that's tricky about that is it could be a very large interval, this is like the first interval, and there could be a lot of other intervals that it overlaps with, but like, well, if the second interval doesn't overlap with anything else, then you just take the second interval, you make the first interval match the second interval. Excuse me. Um, so actually, it's not that bad. I think you only need to look at the first interval. If the first interval overlaps the second interval, then
you can reasonably match those two, because you need something does need to take care of the second interval if they overlap. So then if they overlap, then you can defer. I guess what you would do is you'd set like a window of how many intervals are gonna to the yeah, you have like sort of if they do overlap, you have another sort of index that you're gonna slide, or yeah, another index that's gonna tell you how many intervals will give you the same value. So the first interval will give you the same value, the second interval will give you the same value. If the second interval overlaps with the third interval, then you want to see if see that's also kind of tricky, because the first interval may not overlap with the third interval, right? Excuse me. Oh boy, whoa. If the first interval doesn't overlap with the third interval, but the second interval overlaps with the third interval, you're in an interesting position where you might actually want. No, well, there's no chance of, if the first interval doesn't overlap with the third interval, there's no chance it'll overlap with any of the other intervals past the third. So you're better off taking the x coordinate that you were looking for before for the first and the second, make that just one of the coordinates to take, and then continue, sort of just quote unquote like recurse on the third interval, right? Continue on the third interval with the smaller subproblem. If the second interval doesn't overlap with the third interval, then you actually do the same thing. If the second interval doesn't overlap with so the first interval doesn't overlap with the third, you pick that coordinate. If the second interval doesn't overlap with the third, you pick that coordinate in the same state. If the first interval overlaps with the third, well, if the second doesn't overlap with the third, it doesn't matter about the first. But if the first overlaps with the third and the second overlaps with the third, then actually now you're considering the third interval and what it overlaps with. And things are getting really confusing now, because you have to consider the first, second, and third intervals when you're considering the fourth interval, which is kind of the problem that I was running into. It's like, it's not super simple, this logic. Again, the fourth one, if the third one doesn't overlap with the fourth, then you just take the x coordinate for all three of those. If the third one does overlap, then you have to decide, do you keep the x coordinate for the third? I guess now we're looking at first overlaps with second, which overlaps with the third. Now the fourth is, where's the fourth one? So it's only interesting it's interesting if it overlaps with the third. If it overlaps with the what if it doesn't overlap with the second, but it does overlap with the first? Oh man, that's getting confusing. So the first is very large. The second overlaps with the third, and the first. All three of those overlap. And the fourth overlaps with the third, but and the first, but not the second. How about that? What do we do there? Whoa. Well, we have to get the second, right? The first one that we don't overlap with of the other values, which is actually going to be the minimum of the ones that we've seen so far. That one we need to have something, so we would take its maximum, which up to this point is the third. Yeah. So that's what you would add the x coordinate, and then you'd continue on the fourth. So I think what you do is you consider an interval, right? Sort these things by the x start. Consider the interval and say, all right, we have the minimum ending coordinate of the interval, and we're gonna maintain that as we look at the next interval. So the next interval doesn't overlap at all. Then we add that starting x coordinate to our count and continue sort of as if we popped that first interval off from on the left, which I realize is actually inefficient to do in a vector. But let's say we scroll to the next interval and discard the first interval. Let's say from consideration, right? We'll do it that way. If they do overlap, now we consider the second. Now we consider the second interval. No. We update our ending position with the minimum of those two, which if the second interval is encompassed, then we have a smaller value. If it's not encompassed, then we have a larger value. We still have the first interval's value. Now we don't increment our count yet, but now we're considering the second interval. Then we take a look at the third interval, and we say, okay, is this overlap by the minimum? If it is, then we again we update our minimum if need be, and we're now considering the third. So we discarded the second and the first already, and now we're considering the third, and we don't need to consider the first and the second at all. I think at this point, update our minimum again. As we look at the fourth one, again, if it doesn't overlap, then we take the previous, we increment the count and discard the other three. If it does overlap, then we consider whether or not so I think one of the things that need to be considered is whether or not it overlaps within the minimum, right? I guess the overlap. So I guess that's a question. Is it overlapping with the previous? Are we talking about an overlap with the previous interval? Or are we talking about an overlap with the previous interval and the minimum, right? Because if it's an overlap with the minimum, then we can just update our minimum again and discard the others. If it's not an overlap with the minimum, but it could be an overlap with the previous interval or intervals. So that's a good question. Well, we don't actually care. I think that's the point. So we don't actually care. We only care about the minimum, right? Because if all these other ones are overlapping with each other, it doesn't. We can just take. There's a coordinate we can take to get all of them in one shot, and so there's not really beneficial to bother. There's no benefit to try to take the next upcoming interval and try to overlap with some of the others when we know that there's already one that'll take care of all of the previous ones, right? Because you already have at least two there, one for this new interval and then one for all the other previous intervals. That's two, or you have one for some of the previous intervals and one for this new interval. So in any case, you're going to have at least two. you're going to use. So yeah, so you only care about that minimum, um, because all of those intervals you have to take them at somehow, right? Yes. So I think that's actually the algorithm. So then you really just sort from the start, and as you check out new, um, as you look at new intervals, you update the minimum sort of uh, x sub n, and that's what you use to check for overlap. And if it doesn't overlap, then you add one to your count of required, um, I guess, lines or positions, required positions, and then you update your starting position in this new interval, and you also update your um, minimum end point to that new interval as well. And I think, excuse me, I think that's it. I think that's all you do. Now the question is, how do you sort for things that excuse me, that have the same starting point? I think for the things that have the same starting point, um, do you take the smallest? I don't know if it really matters, actually. I don't know how that plays in, because they're all going to be covered by the same starting point. Um, and I guess ultimately, if you perform the algorithm that we just described, you would end up with them all overlapping uh, with whatever value, whatever order you pick, and then at the end of it, your new minimum would be the smallest one. So I guess it actually doesn't really matter what the order is for the ones that have the same ending point. I'll probably sort them by just because I can. Doesn't not really much more effort. Could probably just sort them by. Excuse me. Actually, I don't think it matters at all. I think yeah, I don't think it matters even one bit. Uh, Interesting. Um, well, well, maybe it does. If the way that I'm measuring the overlap is if the x coordinate is less than or equal to the that minimum y coordinate. No, that they would all overlap, and you'd have to. No, it doesn't matter at all. I don't think it matters at all. You always end up with the minimum. Of all the sets that have the same starting point, x start point, you would have every time you'd end up before you look at the next interval, you'd have you'd be considering the minimum already of all of this, so it shouldn't matter. Okay. So what's the algorithm again? It's yeah. So go interval by interval, left to right, sorting by the x star coordinate, and you don't care about the y coordinate. You don't care about the x end coordinate. You say okay. Um, Update your x start and your x end with the first interval, and then now you're going to check the next interval and say, um, does the x start of the next interval, the next interval, the right neighbor, is that less than or equal to your current minimum end interval? If it is, then you're going to update your current minimum end interval, um, and you're going to sort of discard consider. You're going to update your. You don't actually even need to consider the x start coordinate either. I think. Um, yeah, you don't even care about what those values actually are. You could just increment your minimum x end, and if they overlap, then you don't. If they overlap, you don't need to increment your count. If they don't overlap, you would increment your count. If they do overlap, then you they do overlap, then you update your minimum again. Or I think you update your minimum in both cases. Do you? I think so. Yeah, if they don't overlap, then you're discarding the first one and considering the second one, you're updating your minimum. If they do overlap, you're still updating your minimum. You're incrementing your count this time. You're still discarding the first one. The second one, when that comes around, it's the same thing. If you you can update your minimum. If you overlap with the minimum, then you don't increment your count. If you do, if you if you oh, excuse me. Excuse me. If you overlap with the previous minimum, then you don't increment your count, but you're still going to update your minimum. If you don't overlap, then you increment the count and you still update the minimum. But actually, there is a difference there where you would discard the previous minimums every time. So, yeah. So actually, that's actually there's a difference between those two cases. I think that's all the logic you need. I think it's like really simple. Huh? No kidding. No kidding. Really. Wow. And also, I'm dying over here. Hopefully, I get better soon. I'm like starting to feel pretty sick. I'm giving myself like a headache. I'm coughing so hard. Yeah, milk kind of helps with a sore throat and a cough. Gets your gets the mucus going in your system. I also need to use the bathroom. Let me try coding this quickly, see if it works for some test cases. And I think I got it, but I don't really know. So let me respond to any comments that Yuki may have posted. Or just say respond to the chat. Maybe that's better. Not direct too much attention at any one, any one person. Don't want to make things so personal that other people feel left out, I guess. Follow up on my last question. Twitch had a bathtub meta blow up, and it's just a bunch of girls in bathtubs. Yeah. Also, let me turn on the timestamps for this. I don't know why that happens. I forgot to turn on the timestamps. There we go. Oh, wow. That was... Yuki asked that a while ago. That was 30 minutes ago. Yeah, that's kind of where I thought that was coming from. No, I'm not doing bathtub problem solving streams. That's funny. Appreciate that. Appreciate that. I'll take that as a compliment. Yeah, I think I got the solution for this one. Let's give it a shot. See how we do. See how we do here. But yeah, it's been a while there, Yuki. I have this sneaking suspicion you may have left already, so I'm not going to ask you how are you, but I would ask you if I thought you were still here, I'd say, how are you and what's new, and I guess that's it really, just what's new and exciting. Also, thanks for coming by. I appreciate that. Always like to see you. So, yes, let's write this routine here. Can actually sort the intervals directly, which is kind of interesting. I think I'm gonna do that. Yeah, I'm gonna do it that way. Let's do it that way. So we're gonna do const standard vector int a with the same thing again. And it's going to be a of 0 less than b of 0 excuse me, because we already know what this input's going to look like. And now we can sort these points. Oops. And then I'm going to have a count or ret 0. Something like this. And we're going to return ret at the end of it. And we're going to say int, we'll say a. And we also have a min or previous min or just current min. We'll just say negative int max for now, or int min will do. Let's do int max actually. Come back to that in a second. I'm not sure exactly what that's supposed to be. Points of I of 0. Oops. And then B is points of I of 1. Yes. So now we say we actually only need to consider maybe we always have some. I mean, just thinking, there could be no points, right? There's always at least 1 point. Okay. So this is always there's always at least 1. We could kind of start this off at 1. And actually, in that case, we could set this as points of 0, 1. So this can always go to points.size. And we say if this current min is, I don't know, it's if this A coordinate is less than or equal to this current min, that means that we have an intersection. And this is if we this doesn't overlap here. Overlap sort of next interval overlaps with previous intervals. Next interval does not overlap all of the previous group of intervals. Not overlap with the entirety. Previous group of intervals. Next interval overlaps the previous group of intervals. Next interval does not overlap the entirety of the previous group of intervals. Right, okay. So if it does overlap, then we want to set our current min to be the minimum of, current min is if B is less than current min, then we update B. Currently we update the current min. Consider B. If this next interval does not overlap the entirety of the previous group of intervals, then we increment our count. And we say current min is then just B. Oh, this should be also to B. Is that correct? Something like that. With compiler errors, of course. That works for this case. And these other cases, I think this is supposed to be 4. This other one is 2. This one is 2, or yeah, 4, 2, 2, 4, 2. See how we do on these test cases, and we'll go for some more test cases, I think.
Excuse me. I don't know. If we do like 1, 1. If we do 1, 2. We say 1, 1. We have 1, 2. 1, 3. 2, 4. 5, 6. 100 and 110. 50 and 51. I don't know, I'm just trying different things here. See what we get. Invalid test case. Wait, what? Oh, I see. So 1, 1, I think is the invalid test case. Oh, no, okay. Start greater than equal to end. Oh, all right, sure. Do 1, 4 then. Let's give that a shot. See how we do. All right, I mean that's convincing. I don't know. We could do like another kind of random test case. 50, 51, 25, 26, 100 to 200, 24 to 500. I don't really know. 1 to 2. How about that? Just trying some random things to see if I missed something somewhere. Okay, that's kind of convincing. It probably would take me a while to find a test case that doesn't work. I'm not doing any addition, right? No. I don't know. Let's go for it. No, I'm afraid to hit the button. Hey, got there. Sweet. Wow, 140 milliseconds. Whoa. Whoa. Seems like a lot. Still about faster than 90%. Why is it so slow? Alright, well we got there. It's pretty good. Interesting. It takes a while though. Sweet. So yeah, thanks for watching. That took forever. It took me over an hour to figure it out. I mean, I don't know what to say. Like, interval related questions are really challenging, I guess. They probably are related to sorting and kind of some manipulation after sorting. I really don't know what to say. I think it's just kind of hard, I suppose. Yeah. Well, there was another question I had the other day that was related to sorting and not sorting. I think related to intervals, or was that earlier today? Was it overlaps? What was it? No. That was not interval. No, that was something entirely different. Never mind. But there were a few interval questions I looked at recently that like they're kind of challenging. Like I don't know what to say. They're just you really got to think about them. But I guess more experience makes it a little bit easier. I guess, I suppose. I don't know. I mean, if I knew this answer, it would take me 5 minutes to code it. But like, excuse me, that was like really hard for me to figure that out. You know, that took a while to sort that out. That would be a correct answer. A relationship between like sorting intervals and then kind of moving left to right. I don't know, man. That's all I got. All right. Well, thanks for watching. Talk to you soon. Have a good rest of your day. I think that'll probably be it for me for tonight. So yeah, thanks again everybody for coming by, saying hello. I'm gonna get going. What do I want to say before I go? I don't know if I'm gonna pick up I don't know if I'm gonna pick up another problem before I go. It's probably time for bed for me now. I'm gonna watch something on YouTube and then go to bed. Yeah. So yeah. Okay. Take care. Talk to you soon.